Hello, my name is Ricardo Nakamura and I am a professor at Escola Politécnica, Universidade de São Paulo, Brazil. It's a pleasure to be able to speak at the 5th International Conference on Virtual Reality. I am a member of the Interactive Technologies Laboratory, or Interlab, at the Department of Computer and Digital Systems Engineering. At my laboratory, we have been doing research on virtual reality for nearly 30 years, being one of the first research groups on the subject in Brazil. Our research includes topics on software architecture and interaction devices for virtual reality. More recently, however, we have focused on the development and evaluation of applications of virtual reality for education and training. My fields of research are digital games and virtual and augmented reality from a perspective of interaction design. I have done some research on game engine architecture in the past, but currently my interest in digital games lies in their use for education and health applications. I am also interested in the convergence of games and virtual and augmented reality for the promotion of effective learning. I also teach undergraduate classes on computer graphics, virtual reality, and game design for design and engineering students. Most of those classes involve students from both programs, which allows them to engage in interdisciplinary projects. This has been a great learning experience for me too, as I engage with different perspectives and expectations from students. In this talk, I will present some information and results related to these activities of research and teaching. I will start with our research focused on the application of virtual reality for health education and training. More specifically, I want to present two training simulators developed in close collaboration with researchers of health areas. I will also present our approach to use virtual reality applied to health as a motivator to engage engineering undergraduate students in multidisciplinary projects. To begin this discussion, I will present an overview of virtual reality applied to health. One of the most prolific fields of application of virtual reality technology is health in its many forms. This includes training for surgery and other procedures, decision making, information visualization, rehabilitation, and other therapeutic uses. As such, there are currently thousands of research works in these fields. The contributions include input and output devices, interaction and simulation techniques, design and evaluation of systems, among others. One important gap in the use of virtual reality for health is training of other health professionals. Many of the current works focus on training of students and professionals of medicine. Other professionals, such as nurses and dentists, have specific training needs which are not addressed as often. We have been developing health training simulators with virtual reality for about 8 years at my research laboratory. Currently, we have two main projects, which are Vida Odonto and Vida Enfermagem. Vida Odonto is a virtual reality simulator for students of dentistry, while Vida Enfermagem is focused on students of the nurse school, both from Universidade de São Paulo. Vida Odonto started at about 2015 when professors from the dentistry school talked to us about the possibility of using immersive technologies to help them teach the students a specific technique for anesthesia. So we started the project developing a simulation system which contains a view of the dentistry office with a virtual patient, and the students can interact with the patient using a haptic feedback device, one of the systems using a robotic arm, so that this can simulate the movement of the needle and the syringe with the anesthesia and the contacts with the different tissues in the mouth. This involved the development of simulation techniques for the different tissues, for the injection of the anesthetic fluid, and also different interaction techniques for the navigation, visualization, and feedback of the procedure to the students. This system was continuously developed for several years with validation from both the professors and students at the dentistry school, and currently we have we are developing a new version that involves some elements of gamification in order to further engage the students and promote continued use of the simulator with different scenarios so that they can obtain a learning, better learning results. Vida Enfermagem started a few years after Vida Odonto and was also motivated by the needs of the professors at the School of Nurses to better prepare their students with the procedures involving the collection of blood samples before they actually go to the field, before they actually start working with patients under supervision of the professors. There are economic reasons for that because if they have to make this training with actual physical materials, there is a lot of waste of syringes, of gauze, of various materials that have to be disposed without actual use, just for the preparation and training of the procedures. And there is a matter of scale too, because with a real world physical setup, it's only possible to have maybe 2 or 3 students performing the training at a time if there are enough training rooms for that, and using a virtual simulation system it would be possible to scale this to a larger number of students who can train at the same time. So in this case the focus, like I said, was mostly on the simulation of blood collection. So there are several steps of preparation, from selection of the adequate equipment to be used and contact with the person from which the blood is to be collected, and there is need to explain the whole procedure and see if there are doubts and check if the person is not feeling ill or anxious for the procedure. Then there are several steps that must be performed to actually collect the blood and then stop the puncture point from bleeding. And lastly, there are other points in order to correctly store the blood samples that were taken. So the idea is that the simulator can encompass all of these steps in a virtual setting, and there was research performed along with researchers and postgraduate students from the School of Nurses uh, in order to find the adequate requirements for the simulator and in order to assess their effectiveness. Both projects, that is, Vida Odonto and Vida Enfermagem, have used game engine technology, as is the case for many current virtual reality systems. We have also used emerging head-mounted display technology of comparably lower cost that has been available in the last decade. We have used some specialized interaction hardware, such as haptic feedback devices. However, in order to promote broader acceptance and usage of simulators, we have been doing some research to create lower cost alternatives to allow some precise interaction that does not involve this specialized hardware. There are at least challenges that still remain in the development of simulators for health. One is the need for specialized teams to develop the simulators, even if software tools are friendlier nowadays than in the last decade or so. The other is performing reliable validation of the simulator. There are standard questionnaires for experience, for instance, but since the simulators are used along with other learning techniques, it is sometimes difficult to separate the effects from the use of the simulator uh, and the effects from the other learning techniques, such as lectures and other laboratory practice. Now I want to talk about bringing the experience of designing virtual reality systems for health to our engineering students. The computer engineering course does not include many courses that involve interaction design. There is an emphasis on software architecture, software engineering, hardware, and the interaction between hardware and software. And currently, there are also some courses on artificial intelligence, but interaction design is left mostly to be worked on along with projects developed in other courses. And this is also an important topic for computer engineers because currently there are a variety of devices, not only related to virtual reality, that do not rely on already well-established techniques based on window and pointer, for instance. And it's important that students are aware of this and the challenges of designing systems for all these different kinds of devices and platforms. So virtual reality is an interesting topic because it involves many engineering challenges as well as challenges for human-computer interaction. Like I said before, there are no well-established interaction techniques, although there are several proposed and adopted techniques. It's not as well defined as is the case of two-dimensional interfaces. And there are also many engineering challenges in the integration of different kinds of devices, in the processing of input, and if we start talking about distributed virtual environments, there are a lot of other challenges related to distributed computing and networking. So this was a motivation for us to use virtual reality systems as a topic for a project-based course. However, to promote more engagement, we wanted to have real-world requirements for the student projects. We actually had a few years of the course in which the students could bring their own project proposals, and in the end they were all experimental technology proofs of concept involving the use and exploration of libraries or devices that had little bearing or connection with real requirements. So sometimes there were novel interfaces that did not really solve any specific problem or address the needs of a specific public user profile. And to avoid this kind of situation, we wanted to have real world requirements. So we started working with our research partners from different programs, different institutions, and even companies outside of the university to bring possible themes involving virtual reality and health, because we already have some expertise in research and development of these kinds of systems, and therefore we would be better prepared to advise our students in the development of this kind of project, which also brings another interesting element to the project-based course, because these kinds of projects will be inherently multidisciplinary. So our engineering students will have the need to talk and find out the requirements from a group of users outside of engineering. It's important to note that since students have one semester to complete the projects, they are expected to create interactive prototypes, not complete solutions. Therefore, we asked our partners to provide, if possible, topics of exploratory work rather than ongoing projects. This was an important point in the implementation of our proposal so that the expectations of both students and our partners were aligned, and there would be no expectations, for instance, that the students would create complete solutions or applications that would be ready for use after the end of the course. So the course students were organized in groups and voted for their preferred themes. To clarify, we had about 1.5 months during which we collected these project themes from our partners and talked to them to explain all these requirements like I explained before. And then we presented the collected themes, and the students were able to vote for the preferred themes. Then we tried to work out a distribution of themes that favored their preferred topics for each group of students. This allowed each group to work with a project in which they were truly interested, also adding to the motivation. We have now been conducting this course since August of this year, and currently the students are creating their first interaction sketches to start prototyping. At this point, they are presenting the interaction sketches, sometimes with simulated images, sometimes with very rough interactive versions or proofs of concept developed in a game engine, and they present this to the partners in order to validate the solution regarding the requirements of the problem, and then they will start developing the final prototypes that will be presented at the end of the semester. All this work happens with close interaction between course professors, students, and the external partners who provide the themes. This certainly results in additional workload for the course professors, but we expect increased competencies in interaction design and project management from the students, as well as increased awareness of opportunities involving engineering and health. The developed prototypes might also be used by our research partners as demonstrations or proofs of concept to obtain funding to continue the development. At this point in time, this is still an ongoing project that will end by middle of December of this year. At that point, we will be able to assess the results of the projects developed by the students, the experience of the students during the course, the satisfaction of the research partners, and we want to evaluate all these different aspects of this proposal for project-based learning in order to improve it in future years. But still, it has been an interesting attempt to bridge the aspects of research and development and teaching of the design and evaluation of virtual reality systems applied to health. This concludes my presentation on virtual reality applications for health in research and training. Health is a promising field for virtual reality, and the implementation of training simulations has become more viable due to the lower cost hardware in the last decade. Still, there are some technical barriers for the design and evaluation of training simulators. This topic also has potential to be explored for project-based learning in engineering programs. We are currently applying this in a course. Well, that's it. Thank you for your attention, and I hope you enjoy the conference.